Hi everyone, my name is Max and I am a tooling engineer here at Haas. In this video, I'll provide a brief technical overview of the HMM430's coordinate measuring software, TouchDMIS. I'll demonstrate how to set up and execute a basic inspection routine, giving you a foundational understanding of how TouchDMIS operates within the HMM430 environment. After launching TouchDMIS, the first step is to create a new measurement program. To do this, click on the Haas logo in the upper left corner of the screen and select the icon that resembles a blank sheet. This initializes a new program. TouchDMIS will prompt you to confirm the use of the probe in the A0, B0 orientation. This ensures you have the probe facing forward with the stylus aligned vertically. This is a standard starting point for most measurement routines. Now that I have created a new program and set the probe orientation, the next step is to import the CAD model. TouchDMIS supports both STEP and IGES file formats. To import the model, click on the Haas logo. Select the Load CAD Model icon, navigate to the desired file, and click Open. The model will now appear in the workspace. Before creating a CNC measurement program, it's essential to align the part. Proper alignment ensures that the software can accurately interpret the position of the part relative to the machine, which is crucial for precise measurements and to avoid collisions. In TouchDMIS, an alignment can be completed by measuring three features on the CAD model, typically a plane, a line, and a point, to define the datum structure. For this demonstration, I'll use the 3-2-1 alignment method to define the part coordinate system and to constrain all 6 degrees of freedom, 3 translational and 3 rotational. I'll measure 3 planes for this specific CAD model: the top face, the front face, and the left face. These planes will establish a repeatable datum structure for accurate part alignment. To begin, I'll click the measurement button at the bottom of the interface. This opens a menu with various geometric features that I can measure on my CAD model. Next, I will select the plane measurement icon. A measurement window will appear, allowing me to record points for the plane. I'll click on the top surface of the CAD model and use the joystick to manually probe at least 3 points. Once complete, I'll confirm my measurement points by clicking the check mark in the results window. I'll repeat the same process for the front face and left face of the CAD model. Measuring these 3 planes fully constrains the part, allowing the software to accurately interpret its position relative to the machine's coordinate system and allowing us to create the part coordinate system. With the planes measured, I can now finalize the alignment. I will now select the datum icon at the bottom of the interface to access the datum features, followed by selecting the 3-2-1 coordinate system icon to define the part coordinate systems using the planes I measured. The 3-2-1 method is widely used to constrain all 6 degrees of freedom in 3D space. It requires one feature with a minimum of 3 points to define a plane, restricting 3 degrees of freedom, a second feature with 2 points to define an axis, restricting 2 degrees of freedom, and a third feature with a single point, restricting the final degree of freedom. After selecting the 3-2-1 coordinate system icon, the datum window appears, which prompts the user to select features for the primary, secondary, and tertiary datum. My primary datum will be the top plane, defining the z-axis. The secondary datum will be the front plane, defining the y-axis. The tertiary datum will be the left plane, defining the x-axis. Next, I'll click Equate CAD to ensure that the CAD model aligns with the actual part on the machine. Then I'll select Apply Alignment. After clicking on the Apply Alignment, we can see the CAD model in TouchDMIS shifts to where the actual part is on the machine. The system automatically names the PCS, but it can be renamed by simply clicking the text box. For this demo, I'll leave it as PCS1 and confirm with the check mark. With the part fully aligned, I can now measure features in semi-automatic mode. In semi-automatic mode, TouchDMIS generates the optimal measurement path for the selected feature while giving the user the flexibility to modify the path and other settings as needed. To switch to semi-automatic mode, I'll click this icon in the bottom left of the interface. Once activated, I'll click the measure icon, which displays all available feature types that I can measure: point, edge point, line, plane, circle, arc, sphere, cylinder, cone, polygon, slot, torus, curves, and surface features. The first feature I'll measure in semi-automatic mode is the bolt pattern that consists of 5 cylinders on the top of the part. I'll select the cylinder icon, which opens both the results window and the measurement window. Since I want to measure multiple cylinders, I'll click the Object Measuring List, allowing me to select all of the cylindrical features to create a new measurement chain. As I select each cylinder, the object list populates accordingly. TouchDMIS makes measuring features simple and easy as it allows you to simply click on the feature you wish to measure. In semi-auto mode, I can adjust the measurement depth for each cylinder. I'll do this by using the Measure Path Edit button. Sliders will then appear, allowing precise depth adjustments. I'll repeat this process for each cylinder as needed. We can now see a green dotted path the probe will follow to measure all 5 cylinders. To start the measurement, I'll click Run Measurement. After measuring all 5 cylinders, I'll apply diameter tolerances. To do this, I'll open the Show Feature Results window and enter the tolerances under the tolerance column next to the diameter symbol. And I'll include the results in the report by clicking Add Feature Output to Report, then confirming with the check mark. The next feature I'll measure is a cone. I'll select the cone icon, then I'll select Cone on the part. I'll increase the number of probe points from 6 to 12, and then press Enter to update the path. And I can adjust the measuring depth as needed. Once I am satisfied with the measurement path, I'll click on Run to begin the measurement cycle, and then I'll report the results. The next feature I'll measure is the arc next to this extruded cylinder. I'll simply click on the arc icon and click on the arc I wish to measure. Once I adjust the measurement path, I can click on the Run button and let the HMM do the rest. So far, we've looked at setting up our measurements using the mouse, but it's called TouchDMIS for a good reason. If you're connected to a touchscreen monitor, then you can perform many functions without the mouse. To see how that works, I'll tap on the Construct icon, then the Slicing icon, which opens the Slicing window and Results window. I'll select the normal Endpoint icon, tap on the surface I wish to create my slice on, then I'll click Compute Slices and confirm with a check mark. The software automatically generates a measurement path for the probe to follow along the curved surface. To measure the feature, I'll click on the measurement icon and select the curve icon. Then I can tap on different segments of this curve to set my measurement path. Once the measurement is complete, I can report the data and capture a screenshot for the inspection report. To take a screenshot, I'll open the Hierarchy window, select Features, expand the Curves dropdown, and select the curve I just measured. Then I'll click on the report icon, select the camera icon, I'll frame the model, and click the check mark to take the screenshot. The screenshot is automatically sent to the tabulated reporting window. The tabulated reporting window can be found in the upper right corner along with the TouchDMIS's System Settings, Probe Management, and Workspace features. TouchDMIS makes it easy to edit and manage inspection reports. To remove outputs, simply right-click on the section you wish to delete and select Delete. To edit headers or titles, right-click on the header and select Edit. These tools give you full control over how your report is presented, making it easy to keep results organized and professional. This concludes our demonstration of TouchDMIS. I hope you found this overview helpful and informative. Thank you for watching and see you next time.